Alrighty, we're looking at a superannuation question, and this one has lots of bits to it, so we're going to work our way through it very slowly. First thing you need to is read the question and work out what information they give you. So they want to set up a super fund, and you want to retire in 45 years' time. That's some key information there. And you've got a deposit of $310 each month, and you've got an interest rate of 4.25% compounding monthly. So whenever you see one of these questions, you must write down NIPV, payment, future value, payments per year, and compounding periods per year. So you've got it all sitting in there. Enter it into your calculator, and there'll be one that you're missing. Now obviously for this one, how much will you get after 45 years is trying to find the future value. So you put a question mark next to it. Your payment is $310 per month, remembering that it's minus 310 to make this thing work right for you. So then you go to the calculator, enter in the data, but before you do this you might want to go and set it up so you've got two decimal places. So you go to Shift and then Setup, which is above the menu, and you end up with a window that looks like this. We want to scroll down here to go to our display, and we want to fix our display, which is F1, to two decimal places, and go Execute. And then go, alrighty, we get out of that. So now we're going to have two decimal places everywhere, which means that we get the right dollars and cents when we're doing those calculations. So we come down to our payment, which is going to be minus 310, execute, and then we want to find out our future value, which is done by hitting F5. And our future value will be $503,045. So future value 503.45.2. 045.29. So that's our future value now. So when you go repeat, all your numbers are in your screen ready to roll. So that's the first part of the question. Let's go to the next one. The next part says you roll this over, which means you're going to grab that money and turn it into a pension, and you're going to be paid 6.1%, and you want to find out how long your money lasts. So what we have done is we take our 503,000, which was our future value, and we put it into our present value, because we've been saving up that money. Now we have it in a lump sum, and we're going to start drawing money out of it, so it becomes a present value because the lump sum of money exists now. So then what we do is we put in payment as 3,500, our I is 6.1, we're trying to find N. Notice that future value is now 0, payments per year and compounding periods per year are still 12. So if we pull that up, we've got all our numbers in there. So we want to move up to here and put a 0. You can put a 0 for your N. You want to change your interest rate to 6.1. We want to write in our future value now goes into our present value, because that's how much money we're going to be drawing out of. And then we want to come down and change this payment to $3,500, so minus 3,500. It's got to be minus because you're drawing the money out of there, and future value you've got to put as a 0, okay, because you don't want any money in the future. And then we're trying to find N, so if we solve for N, we end up with 258.68 months. So that was 258.68 months. Now notice, whatever our payment per year is what the answer for N will be, okay? They'll be in the same kind of terms. So if that's monthly, your N's going to be monthly. If it's quarterly, your N will be quarters. So if you wanted to, you could grab the $258, or 258.68 months, divide it by 12, and that'll give you years, which is about 21.56, 21 and a half years is how long your money will last for. So that's not too bad. So on your calculator, it will look like the windows that you'll end up having will be like that, with all the numbers and stuff in there, noticing that they've now got the 258.68 months sitting up there. Let's go to the next part of the question. The next part of the question says, if you wanted your money to last for 25 years, how much would you get each month? So now we've got the same, still got all the data in our calculator, but we're trying to find the payment. So we put in N equals 25 by 12, I stays the same, your present value is still in there, your payment is the one that you're now missing, future value is 0, payments per year are 12, compounding periods per year are 12. So on your calculator, you've got to come back into here, go into N, change that to 25 times by 12, go execute, 6.1's there, that's all there. We don't know what our payment's going to be, so you can either put 0 there, or just go to F4 and it will work it out for us. So it gives us a payment of $3,271.95. $3,971.95. So that will give us how much money per month we're going to get if we want our money to last for the 25 years. So that's pretty good, you know, 3,200 if your money's going to last for 25 years, which is pretty good. The next part of the question is this last bit. If you're after 10 years into your retirement you have a medical condition which means you need to have an extra $220 per month, how much longer will your money last? So this is quite a complex question because you've got to find the balance, you've got to find how much you've got after 10 years, and then change your payment to see how much longer it's going to last. So it's a couple of steps to it. But we use a different window on the calculator. We use the amortization button. So on your calculator you'll have an answer like this, which is your payment of $3,271.95. If you hit AMT, another window comes up with a payment 1, payment 2. Notice that you've still got all these things still here on the screen, but you've still got a payment 1 and a payment 2, so you've got a new bit of your window opening up here. So payment 1 is the first payment you're looking at, payment 2 is the last one. So we're going for 10 years. So our payment 1 will be 1, our payment 2 will be 10 lots of 12. So it's going from the first payment to the 120th payment, and we're trying to find out the balance. So you're entering 1 there, 120 there, and you have all these numbers down the bottom here, all these functions down the bottom. We want to grab balance. So if we hit balance, which is F1, what happens is we end up with 385,266. 385,266, and I can't remember the last number, 0.34. 0.34. So that's how much money we've got left over in our account after 10 years. Okay. Now what that means is we are now going to do a new calculation with that as our present value and increase our payments. So you'll come across to here. Your payment 1 on your screen, you've still got, if you go repeat, you'll have payment 1, payment 2. You don't necessarily need that, but you can either leave it in this window or you can go F6, which will take it back to that window, because what we're trying to find now is to try to find out what our N will be, because how much longer our money is going to last for. So now in this bit here, we enter in the balance that we calculated before, the balance after 10 years. So our calculations told us that our balance is 385,266. So we have to put in here, our present value is 385,266.34. Just check that. 266. Yeah, beautiful. So our balance is this new balance. Our payment is going to be whatever our new payment is, because remember that at the moment in our calculator our payment is minus 3,271.95. So in our calculator we've got that number already for us. So in here it's really good to write it, minus 3,271.95. Just check that's right. Beautiful. Now we have to increase this payment here by $220. So it's got to be $220 bigger, but because it's going negative we take it away. So this is our balance from the question before. This is what our new payment's going to be, and we're trying to find our N. Okay, we're trying to find out how much longer our money is going to last for. So we go back into our calculator, change our present value across to the new balance, which is 385,266.34. It's handy to write this down on a bit of paper because then you get it right. And then for this one here, you can just scroll across. I'm hitting the arrow button here on my replay button, and I get through to the end of my numbers, take away, I can't quite see it, take away the $220, and you'll notice now that it's $3,491, because that means that we are actually paying more, or more is being taken out now each month. Our future value is 0, our present value is going to, payments per year, sorry, are going to be 12, our compounding periods per year is still 12. We're trying to find out what our new N is. So if we go to F1, we'll end up with 162.29. So our number of years be 162.29, but we've already been going for 10 years, which is another 120 months, because remember this is in months, which means that if we add those two together we can work out how much time our money is going to last for. So 162.29 add 120 gives you 282 months. And then if you divide that by 12, you can find it's going to be 23.5 years. So if you do have a nasty fall, that instead of your money going for 25 years, is what the question you kind of worked out to do, you'll only get 23.5 years. It doesn't make that much of an impact, but remembering that the $220 which is being taken extra isn't that large. So just repeating what you do, you grab your balance from the question before, that becomes your new PV. Your payment gets bigger, so it's going to be minus $3,491.95 per month. All the rest stays the same, and you're finding your new N. That's how much longer this money will last before it gets to nothing. But you've already been going for 10 years, so you've got to add that over here to the 10 years that you've already been going for. To use your 282.3 months, you divide that out and you get 23.5 years. So quite a complex question, but with all these questions, just work systematically through them. Start at the beginning, keep on going till you get to the end, and you'll find that you'll be able to solve it. No worries. So that is probably the most complex kind of super fun question you'll get, and I hope that kind of makes sense.